Hey guys, welcome to math lesson on indices, and in this lesson we're going to introduce you to all the basic index laws and how to apply them to simplify or solve equations. And hopefully by the end of this lesson you will have a good grasp on indices. So what are indices? Basically, if you think of a number multiplying by itself, so for example 3 times 3 times 3 times 3. Now you are writing times 3 repeatedly quite a few times. And in maths we like to shorten things, okay? We like to think of ways to shorten things. So if you remember, for example, 5 plus 5 plus 5, we write that, actually plus 5 again. The short way of writing that is 5 times 4. Okay, so if we have something like this, 3 times 3 times 3 times 3, the short way of writing that is in index notation, and we have 3 to the power of 4. Okay, so 3 is called the base, and 4 we call the power, or some people say it's index. Okay, so that's basically what indices are, dealing with powers. Okay, so let's explore the first index law, which is a to the power of m times a to the power of n equals a to the power of m plus n in the power position. So that's law number 1. Index law number 1. Okay, so where does this law come from? Well, if you think of it this way, let's say we have 3 to the power of 4 times 3 to the power of 5. Now, if we're going to write that out, 3 to the power of 4, similar to what I just proved to you here, 3 to the power of 4 is 3 times 3 times 3 times 3, so 3 times 3 times 3 times 3. Times 3 to the power of 5, so 3 to the power of 5 is, 3 to the power of 5 is 3 by 3 by 3 by 3 by 3. So how many times are we multiplying 3 by itself? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 3 to the power of 9. And where does the number 9 come from? Well, that 9 is the same as 4 plus 5. Okay, so therefore in general this rule works. So that is the first index law. Now the second index law says, actually let me just start a new page. So index law number 2 says a to the power of m divided by a to the power of n is a to the power of m minus n. And this might sound a little bit hard to understand, but if we use our example again, 3 to the power of 4 divided by, let's say, 3 to the power of 2. Now, if you remember, dividing is the same as writing a fraction, where we write the first number on the top and the second number on the bottom. Okay, so 3 to the power of 4 divided by 3 to the power of 2. Now 3 to the power of 4 is 3 times 3 times 3 times 3. 3 to the power of 2 is 3 times 3. Now anytime we have a number divided by itself, it cancels down to 1, right? If you remember, 3 divided by 3 is 1. Okay, so 3 divided by 3 is 1, so we can write 1 there. Alright, 3 divided by 3 is 1. So what do we have left? We have 3 times 3 on the top, divided by 1, which is just 3 times 3, which is just 3 to the power of 2. Now where did the number 2 come from? Well, the number 2 comes from 3 to the power of 4 minus 2, which is 3 to the power of 2. So that is a lot quicker. So that is the second index law. And let's do the third one. The third index law says that anything to the power of 0 is 1. Index law 3. Anything to the power of 0 is 1. And so where is the reasoning behind that? Well, for example, if we have 3 to the power of 3 divided by 3 to the power of 3. So we have 3 by 3 by 3 on the top, 3 by 3 by 3 on the bottom. So then we cancel the numbers down to 1. Alright, so we're just left with 1. Now 3 to the power of 3 divided by 3 to the power of 3, using our second index law, that will be 3 minus 3, which is 3 to the power of 0. So 3 to the power of 0 is the same thing as 1. So that's why anything to the power of 0 is 1. Okay, let's do rule number 4. So index law rule number 4. We have a to the power of m to the power of n is a to the power of m times n. And how does that work? Well, for example, if we have 3 to the power of 5 to the power of 2, well, that is going to be the same thing as 3 to the power of 5 times 3 to the power of 5, correct? Because that's what to the power of 2 means, multiply by itself. So now we have 3 by 3 by 3 by 3 by 3 times, again, oops, and how many 3's do we have? We have 3 to the power of 10. Now a quicker way of doing that is just 5 times 2, inside power times outside power. So 3 to the power of 5 times 2. Okay, so that's law number 4. Law number 5. If we have something like 2 terms inside the bracket, AB to the power of n, then it is the same thing as a to the power of n, b to the power of n. Okay, and that makes sense with numbers as well. So for example, if we had 3 times 2 to the power of 2, okay, so 3 times 2 is 6, to the power of 2 is 36, or we could write it as 3 to the power of 2 times 2 to the power of 2, which is 3 times 3 is 9, 2 times 2 is 4, which is also 36. So I'm just proving these rules to you by example. The last couple of rules, let's see what else we have. Indices and fractions. So we have, what number was that? Rule number 5. Let's do rule number 6. Rule number 6. A over B to the power of m is a to the power of m over b to the power of m. Okay, so how does that work? Well, again, let's do a numerical example. Let's do 3 over 2 to the power of, let's say 2, just to make it easier. Okay, so 3 over 2 to the power of 2, let's just evaluate it as we would normally, times 3 over 2. 3 over 2 times 3 over 2, that's 9 over 4. Okay, so that's doing it normally. Now let's do it with using the rule. So we got 3 over 2 to the power of 2 is the same as 3 over 2 over 2 to the power of 2. Using the rule from up here, 3 to the power of 2 is 9, 2 to the power of 2 is 4. So these two are exactly the same. Okay, so proven number 6 rule to you by example. And now let's do the negative index law, rule number 7. Negative indices. So if we have something like a to the power of negative m, that actually equals 1 over a to the power of m. Okay, so how does that work? Well, if you remember, let's say we have 5 to the power of 3 divided by 5 to the power of 4. So that'll be 5 to the power of 3 minus 4, which is 5 to the power of negative 1. Now, if we write it out using full expanded notation, we then have 3 5s on the bottom, 3 5s on the top, 4 5s on the bottom, and we cross them out one at a time. So 5 divided by 5 is 1, 5 divided by 5 is 1. So we're left with 1 on the top, 1 times 1 times 1, 1 times 1 times 1 times 5. So that's 1 over 5. So these two things are equal. Right? As I have just proven to you, 5 to the power of 3 over 5 to the power of 4 is the same as 1 over 5, which is 5 to the power of negative 1. So, proven that to you by example. And what that basically means is, for example, if I was going to write 3 to the power of -3, I can get rid of the negative sign and put it on the bottom of a fraction. And if I have something on the bottom of a fraction, let's say 1 over 5 to the power of 2. Okay, it doesn't have to be 1 on the top. It can be any number on the top. I can say I have 5, let's say 12. Okay, I can rewrite that as 12 times 5 to the power of -2, and so on. So that's rule number 7. Okay, so let's do some of these questions using the index laws. Okay, so starting a new page. Okay, so simplify the following. Using index laws. Number 1, let's put down 5x to the power of 5 times 4x to the power of 3. 2, let's do y to the power of 3 times y to the power of, times 2y to the power of 4. Let's put one with multiple numbers, xy to the power of 2 times x3 to the power x to the power of 3, y to the power of 4, something like that. Let's do a fraction one, 15x3 over 20x to the power of 2. Okay, so I'll give you a minute to do them and then come back and we'll do the answers. Okay, so the first one, we're going to take care of the numbers first. So 5 times x to the power of 5 times 4 times x to the power of 3. You can pretend there's a times sign there because in algebra, when we have two terms multiplying each other, we just don't write the times symbol. Okay, so 5 times 4 is 20. X to the power of 5 times x to the power of 3 is x to the power of 8, using our first index law. Okay, this one we got 1 in front of y cubed. Remember, if there's no number written there, it just means 1. So 1 times 1 times 2 is 2. Y cubed times y squared is y to the power of 5. Times y to the power of 4 is y to the power of 3 plus 2 plus 4, which is to the power of 9. Third one, we have x to the power of 1. Remember, if there is no power in there, it just means to the power of 1. So x to the power of 1 plus 3 is 4. Y to the power of 2 plus 4 is 6. And the last one, 15 over 20 is 3 over 4. So 3x cubed over 4x squared. Now, if you remember our second index law, 3 minus 2 is over 4x to the power of 1. Okay, if you've forgotten how to do that one, just remember we have 3 x's on the top, 2 x's on the bottom. So when you cross them out one by one, you have to cross one out from the top and one from the bottom at the same time. So you're left with 1 x on the top. Alright, so it's 3x to the power of 1. If I had changed this question around so that we had 3 on the bottom and 2 on the top, okay, I'll show you what that makes it become. So let me just rub all this out. So if I had, for example, 4 to the power of, 4x to the power of 6 and x to the power of 3 on the top, then what happens is, well, we got 3 times x times x times x, and we got 4 times x times x times x, 6 x's multiplying each other. So when you cross them out one by one, you're left with 3 x's at the bottom, so 3 over 4x cubed. Now the quick way of doing that is just get the larger number, which is 6, minus the 3, and write it on the bottom. So 3 over 4x cubed. Okay, so these are the simpler ones. Now let's do some more advanced ones with which utilizes more harder index laws. So let's do m to the power of 4 n to the power of 2 times, let's put a negative 1 in there just to make it really hard, and negative 2 and 3 over x, actually let's stick with m and n, mn to the power of 3, and let's make this whole thing to the power of negative 1, just to confuse you. Okay, so let's deal with the inside first. Okay, so let's deal with the most inside bracket. Leave the negative 1 there. Okay, let's deal with the inside bracket. So m to the power of 4 to the power of 2. So actually do this question by yourself first. Take a minute to do it and then come back to look at the answer. Okay, so we have m to the power of 4 times 2 is 8. N to the power of 2 times, now when you have negative 2, what happens is you can just move this whole term down the bottom and get rid of the negative sign. So you can pretty much just write this number down the bottom and just write the 2 there. Okay, now we have times n to the power of 3, and this term here is m to the power of 3, n to the power of 3. Okay, now simplifying what we have in the brackets, we have m to the power of 8, n to the power of 5 over m to the power of 5, n to the power of 3. Okay, so now we have 8 minus 5 is m to the power of 3, n to the power of 2. Now we have to the power of negative 1. And if you remember, x to the power of negative 1 is 1 over x. So you can just write this as 1 over m to the power of 3, n to the power of 2. Like that. Okay, so this pretty much sums up our index law tutorial. I hope this has helped you with doing index laws, and see you next time.